Hello everyone, welcome to Big Data Thoughts. Today we are going to talk about Azure Data Explorer. So in the past videos, in the series of Synapse Azure Analytics, we have spoken about what is Synapse Analytics, what is Azure SQL that is used in Synapse Analytics, and today we are going to talk about yet one another component which is part of the Synapse Analytics called Data Explorer. So let's get started. First of all, what is Azure Data Explorer? So, Synapse Analytics, when it was built, the whole thought process was to have all the features that are present in a data warehouse and a big data solution. So, combining both of them together, the thought of Synapse Analytics came out. And in that, Azure Data Explorer is targeted to do big data analytics, and it is a platform that can help you in doing big data analytics and analyze high volume of data in near real time. That is what Azure Data Explorer does. We can look at it as a toolbox that gives end-to-end solution for data ingestion, query, visualization, and data management all put together. So that's Azure Data Explorer. Azure Data Explorer provides interactive query experience. It is meant for working on large volumes of data. It can give insights from log and telemetry data. And if you look at the Azure Synapse Analytics architecture, this is the Synapse Analytics architecture. There are three analytic runtimes that Synapse Analytics provides: SQL, Apache Spark, and the third is Data Explorer. So this Data Explorer is an analytics runtime that can be used to get insights from log and telemetry data. It can give you interactive querying experience. One of the biggest feature that it has is that it has a powerful indexing technology. So it can automatically index free text, semi-structured data, and any kind of data. So it's not just restricted to structured data, but it can work with free text and semi-structured data also. And it automatically, the moment you ingest data into Data Explorer, it indexes that data, which gives a very good performance when we are doing interactive queries. Other features that this Data Explorer has is like I said, it's an end-to-end solution which is used for ingestion, querying, visualization, as well as data management. So it provides a lot of integration points to ingest data from various data lakes, or you can use Apache Spark, SQL engines to do data integration. It helps in doing the entire index maintenance. So it creates indexes on its own and maintains them. So there is no need for us to do that. It does not have any complex data modeling. It has its own query language which is optimized for doing the interactive queries, which is called Custo Query Language. And one of the other things that we spoke about some time back also is that it has independent compute and storage scaling capabilities. So it doesn't restrict you to scale both, even when you need just storage. So you can scale them independently. These are very powerful features for any analytics engine. Then if we talk about the overall architecture, so Data Explorer pool, so it has its own pool and it implements a scale out architecture. The storage and compute, like I said, are independent. So what it does is it has two different sets of computes. One is just used for indexing, compressing, caching, and serving the queries. The other set of compute nodes are used for data management services, which are like background system jobs or managed and queue data ingestion. So because of these two separate set of computes, the queries become very performance efficient. Any data that is ingested into Data Explorer gets stored in a separate blob storage, and that data is compressed and stored in a columnar format, which gives a further performance boost. Now let us talk about few of the concepts that are important to know when we want to understand Data Explorer, or why Data Explorer is performance efficient, or how does it work. So one of the core concept is Azure Data Explorer cluster. So whenever we are using Azure Data Explorer, there is a cluster running in the background. Now each Azure Data Explorer cluster can hold up to 10,000 databases. That's the max limit. And each of the database can have up to 10,000 tables. So essentially, when you're using Data Explorer and it is meant for big data, you can actually store huge volumes of data. Internally, when this data is stored in the table, it is split into data shards, which are also known as extents. It shards the data or chunks the data into multiple units, and that data is automatically indexed and partitioned based on the ingestion time. So whenever we are ingesting data, it is automatically getting indexed and partitioned. One more important thing to notice, in relational databases, we always had primary key, foreign key, and all those uniqueness incorporated, or there were constraints that you could impose. But here, and if you talk about any big data solution, whether NoSQL solutions or Hive or these kind of solutions, they do not have the constraints of primary, foreign key. And one of the reason is that since the data is distributed, it's a very different kind of an architecture. If we enforce these kind of primary, foreign key, it takes a toll on the performance. So even Data Explorer does not have those kind of constraints. So when we talk about these constraints, there are always pros and cons, right? Some people may say not having a primary and foreign key is a problem, because now you have to manually ensure, manually I mean by your own code, you need to ensure that those uniqueness are incorporated if you want that, right? But it has a positive side to it, that the performance is much better, because in a distributed setup, if we try to impose those kind of restrictions, it becomes very difficult, because data is not at one place, it is distributed. So ensuring that the primary key constraints are maintained, foreign key constraints are maintained, takes a lot of effort on the performance side, and it hits the performance. So Data Explorer does not have any of those constraints. Now, Azure Data Explorer database, as I said, can have like 10,000 databases, each can have 10,000 tables, but there are two types of tables that Data Explorer has. And we know we have been seeing these kind of tables in Hive also in the past. So one type of table is which are made up of a set of columns, and each columns has one of the 9 different data types. So there are 9 data types that it supports, and there can be internal tables, a table which are just internal, and there can be external tables. External tables are where underlying storage is in some other location, and we are just pointing to it or referencing the data. So it can have both types of tables. Now, data ingestion. What kind of data ingestion can we do in Data Explorer? It supports both batching and streaming. So when we talk about batching ingestion, that is optimized for high ingestion throughput and fast query results, because we are talking about big data. Streaming allows you to ingest near real-time data. So both of these modes are supported. And data, even when we are inserting data, there are different modes in which we can insert. We can have our own managed pipelines using Event Grid, IoT Hub, Azure Data Factory. So it has a lot of integration touch points. There are connectors and plugins to Logstash, Kafka, Power Automate, Apache Spark. All of those connectors can be used. We can also do programmatic ingestion using SDKs or light ingest. So there are various ways in which data ingestion can be done into Data Explorer. Now coming to the data analysis. So data analysis, it uses a query language called Custom Query Language, KQL. It's a proprietary query language for Data Explorer, and it reads the compressed and column format data from a blob storage or any storage that we are pointing to. The KQL is optimized for fast flowing, diverse and big data exploration. Queries, reference tables, views, function, any other tabular expressions. So basically data analysis, when we are ingesting data, we can ingest from various sources and we can analyze that data. That data can be in tables or different databases. It's not restricted to having data only in one of the, like in any one form. We can connect to different types of databases, even clusters. The other part of it is the visualization. So Azure Data Explorer has a web UI. We can visualize and run our queries there, build dashboards. It can support up to 500k records and thousands of columns, because it is meant for big data visualization. Now Azure Data Explorer also has ODBC, JDBC connectors. So you can connect to Tableau, Click. It doesn't restrict you to use only Data Explorer web UI. There are native connectors which can be used to connect to Power BI and Grafana. So there are various ways of visualization in a Data Explorer. So if you see now, we have spoken about ingestion, about querying, about visualization. So all of these are at one place within Data Explorer. Now one of the most important questions is when to use Data Explorer. So any kind of analytics that we want to do on log or telemetry or any big data, where we want to do this end-to-end kind of scenario of ingesting, querying and then visualizing also, we can use Data Explorer. We can build IoT analytics solutions. We can consolidate and correlate our logs and events data across systems, on-prem, cloud, third-party. We can draw analytics. We can build any kind of analytics SaaS offerings. We can do pattern recognition, anomaly detection, forecasting. So it's just an example, the use cases that I have talked about here, but there can be a variety of use cases that we can implement using Data Explorer, because ultimately it's nothing but a analytics solution or an analytic helping you to do analytics on huge volumes of data. So that's all about Azure Data Explorer. I hope this has helped you to get a quick stab at what Azure Data Explorer is, where it can be used and how does it work internally, what are the features. So please like, share and subscribe to the channel to get more interesting videos. Thank you so much.